Hello, my dear friends. Welcome to another lecture on linear algebra. In the last lectures, we have studied row picture, column picture, Gaussian elimination, and how to look into the row picture and column picture along with the singular cases. In this lecture, we will study about matrix notation. So we will see what notations are used to write the matrix. Now let us do this using an example. So let our equations be. This is our first equation. Our second equation will be 2u plus 5w equals to 7. Our third equation will be 3u minus 4v plus 7w equals to 6. So this is our third equation. Now here we have 9 coefficients. This is the coefficients of the variables. So here total we have 9 coefficients. This is 1, 1, 1, 2, 0, 5, 3, minus 4, 7. So what we do is that we write our 9 coefficients in the form of the matrix. Let us call that matrix as A. So this will be 1, 1, 1, 2, 0, 5, 3, minus 4, and then 7. Now the another vector that we will use here is the x vector. So let us write it as x. So this will be a vector of variables. So here our variables are u, v, and w. So we will write our x vector as in the form of column. So u, v, and w. Now the only remaining part here is the right hand portion. So we will denote it by b. So our b will be a column vector again. It will be 3, 7, and then 6. So here we have the coefficient matrix A, unknowns in a column X, and then right hand side in a column B. So the way we write it as AX equals to B. So here A is a square matrix, X is a variable vector matrix, B is also a variable, B is also B is the right hand side matrix. So here A is a square matrix. So this is of size 3 cross 3. That is, there are 3 rows and 3 columns. So if we have n equations and n unknowns, so we will have a square matrix. Now if we have m equations and n unknowns, so in this case our matrix will be of size m cross n. That is, we will have m rows and n columns. So it will be a rectangular matrix. Now let us go to our this x vector. This column matrix that we have written here, this can also be treated as a vector. In fact, all the matrices behaves like a vectors. Now why do we say so? Because we can add the vectors, we can add the matrices element wise, and when we multiply by constant c, all the elements get multiplied by that constant. Let me show that using an example. Write b here. So our B is 3, 7, 6. Now let us take two matrices and then add those two matrices. So our matrices be, let this be 1, 2, 3, 4, 5, 6. Now we can add it to the another matrix. So let it be 1, 1, 2, 2, 3, 3. So now adding this to how we can add is we can add element wise. 1 will be added to 1, so it will become 2. Now 2 plus 1, so it will become 3. 3 plus 2 is again 5. 4 plus 2 6. 5 plus 3 8, and 6 plus 3 9. So you can see how the matrix addition is done. It is done just as we add the vectors. Now we can multiply this matrix also by some constant c. So let us multiply it using 2. So let our matrix be 1, 1, 2, 2, 3, 3. When we multiply it by 2, what we get is 2, 2, 4, 4, 6, 6. So we have matrix addition and matrix multiplication. So it is done in the form of just like as vectors. So we have the equations here. We have this a, x, and b. Now what we can do is we can write these equations in the form of matrix. So let me clear this. So this is our A matrix. We can write X matrix adjacent to that A matrix. So it will be U, V, W. So this will be equals to nothing but B, that is 3, 7, and 6. So this is A, X equals to B. So this is how we can write our uh, equations in the form of matrix equations. Now we saw matrix addition and we saw matrix multiplication by a constant. Now to get this portion here, that is Ax equals to B, we need to know how to define the multiplication. So we will define the multiplication such that we get this form of matrix. So the first row here is 1, 1, 1. When you multiply it with u, v, w, you get 3. So we can write it here as 1, 1, 1 multiplied by u, v, w. So this will be nothing but u plus v plus w. And this will be equals to the right hand side 3. Similarly, we can do it for our second equation. So instead of 1, 1, 1, we can write 2, 0, 5. So this will be 2u plus 5w equals to 7. Now we can similarly write for our third portion, that is 3 minus 4, 7. So this here portion will be 3u minus 4v plus 7w equals to 6. Now we see that the row multiplication with a column, this will gives us a inner product. So product of the matrix 1 cross n, that is 1 row and n columns multiplied with n cross 1, that is n rows and 1 column, this will give us a 1 cross 1 matrix. This will be nothing but the dot product of these two matrices. So this is 3 times u minus 4 times v plus 7 times w. Uh, so let us instead of this uvw, let us take numbers so that it can become more clear to you. So let our numbers be 2, 3, 4, and then this is a 1 cross 3. So here we will need to have 3 cross 1 matrix. So it will be, so let it be 4, 5, and 6. So when you do the multiplication, so it will be nothing but 2 cross 4 plus 3 cross 5 plus 6 cross 4. Now you can simply add this. So this will be 18 plus 15 plus 24. So 32 plus 15. So it will be 47. So multiplication of these two, here first the row and then the column, this will give us the dot product of these two vectors. So here we saw that multiplying this row with this column will give us this part. Now there is another way in which we can write this ax form equals to b. This is nothing but you take one of this variable, that is u, then take another variable v, and then take another variable w. So you can write this as u times, so this is the first column 1, 2, 3, because our u only gets multiplied by the first column. Now you can add v to it, adding v to the by multiplying it to the second column, that is 1, 0, minus 4. Now u, v, and last is w, it will be 1, 5, 7. So this will be nothing but our matrix 3, 7, and then 6. Now in the so this is the column picture that we have seen in the previous lecture. So this ax is nothing but a combination of columns of a with the variables in the x vector. So what we have done here is we have represented the matrix in the form of a, our variables in the form of x, and our right hand side in the form of b. But now the notation that is remaining is how do we represent each element of a matrix. Now to represent each element of the matrix, we do it using the row number and column number. Now if we have a vector, we need one subscript for that, that is this is a x vector. So what we can do is we can write x1 nothing but u. For x2 this will be v, for x 3, this will be w. Now the matrix case, now in the matrix case, you will need two subscripts, that is the row and the. So our a11 will be nothing but 1. Similarly, a first row second column will be nothing but again 1. Now this 2, this will be nothing but a second row first column, so this will be nothing but 2. So now we have seen how to get how to write this elements of the matrices. So here we have seen the matrix A, the matrix X, the matrix B. We have seen how to write the elements of A, how to write the elements of X, how to write the elements of B. We have seen how to multiply this A to the matrix to the column matrix X, so that we can so that our equations we can write it in the form of matrix. Now to see this product AX, we can use the summation symbol. So we have this sorry this interruption. Now uh, uh, we will see how to write this product AX. So what we'll use here is the summation symbol. It means summation, that is, now as we do in the product, we will need to add the elements. So let us take an example. So let our A matrix be a square matrix, that is of the form A11, A12, A2, A22. Let us have our vectors, that is x1 and x2. So this will be nothing but b1 and b2. Now our first component here will be nothing but a11 x1 plus a12 x2. So this is our first component, so this will be equals to b1. Now how we can write it in the form of summation is that we can take the ith component. Here this is the first component, so for any ith component we can write it as, for j equals to 1 to n, a ij times xj. So for I equals to 1, this is a1, starting from j it goes to n, so it will be a11 x1 plus a12 x2. Similarly we can write for the second element, so let us do it for the second element. So for I equals to 2, this will be a21, j starts from 1, x1 plus a22 x2. As we have two elements only, we ended 2, so this will be nothing but b2. Now one thing to note is that the length of the columns in A must match the length of the x vector, that is, this length should be equals to this length. So our m cross n matrix will multiply a n dimensional x vector. Now in our upcoming lectures we will see matrix multiplication and how do we decompose our matrix A in the form of L U. So in this lecture we saw the matrix notation, we saw how to write our equations in the form of in the form of our matrix A. We saw our column vector x, our variables, and then on right hand side B. We saw how to write the equations in the form of Ax equals to b. Then we saw how to notate each of the elements of the matrix, and then we saw our summation part. Now in our next lecture we will see matrix multiplication, and then in our further lectures we will see how to decompose our matrix A into lower triangular and upper triangular matrix. So that is all in this lecture. Hope you all like the lecture. Thank you for watching.